Welcome to TFR Insights, and today we are going to talk about Apache Cassandra in the container world. We have two guests with us, Ben Bromhead, CTO of InstaCluster, and our regular Patrick McFadin, VP of Developer Relations at DataStax. Ben, this is the first time I'm hosting you on the show, so please tell me a bit about the company and your engagement with the Cassandra project and community.
Thanks so much for having me. So Instaclustr, first and foremost, we're a managed data layer company, right? So we look after all the various technologies that you would use, essentially to store data. We got our start actually providing a managed service around Apache Cassandra. And we really just listened to our customers and looked at what are the other things that they're using to build, highly scalable, highly available applications like Kafka, Spark, Elasticsearch, Redis, all those fun things. We do them so that our customers don't have to do it themselves.
Patrick, we have done it so many times, but it doesn't hurt to just remind our viewers what DataStax is all about.
So DataStax, we're a company founded around supporting Apache Cassandra. We do everything from an enterprise build to Cassandra as a service now. That's our DataStax Astra. We have we're working with Apache Pulsar now as well. So there's some things going on there, but mainly my job in the world is working with the open source project.
Now let's talk about the topic, which is containers and Cassandra. I mean, containers traditionally is like, stateless, and though now stateful workloads also run there, but databases are not considered to be something, you should be doing. It could be, of course, reliability could be an issue, performance is an issue, and because the funny thing with containers in today's world is most people actually don't even know what is running in their container. They just pull it from some public repository and it starts spinning. So let's talk about what are your thoughts on, not just Apache Cassandra, but a database in general running in containers. So either Patrick or Ben, you can start.
Ben, go ahead, because I think we both see eye to eye on this. We've had many discussions on this.
First of all, I think there is definitely a lot of uncertainty and doubt around should you run databases in containers, right? There's a lot of concern. You can see people angsting about it on Twitter, and I think there's some good reason. But at the end of the day, a container is just another way of running a process on Linux, right? And, there's a lot that goes with it, and there's a lot in the ecosystem that can make it tricky, but, you can certainly run databases in containers. Here at InstaCluster, we've been running Apache Cassandra in containers, since Docker was 0.3, right? Since before it was actually a good idea. And, really it comes down to thinking about it a little bit carefully, looking at what it gives you out of the box and making sure you understand what that actually means from a database perspective. But yeah, you can certainly do it. I think the ecosystem around containers can certainly get people tripped up, but it's very, very doable. And I won't go too much into the ecosystem just at the moment, but I'll throw it back over to Patrick for his take.
Well, I mean, here you have two businesses that are running on containerized databases. And so, of course, we believe it works and we're staking a business on it. But I think one of the things that's really important is that you can't rely on defaults. And maybe that's where people get tripped up. Of course, if you choose to Docker pull Cassandra and run it, you're probably going to be a little disappointed because you're not thinking about what it's actually going to need. And it's mainly around network and storage, especially storage. But, it just a little bit of knowledge about how Docker works. And like Ben said, it is a running process in Linux. There's a few more steps there, but it can really, if you take a few minutes it's not that long either. Take a few minutes, learn how it works. It can make your life a lot easier.
Of course, I'm throwing some questions, but if there any point that you two want to argue or discuss, feel free to jump in there as well. That will be actually even more interesting for me.
Oh, Ben, shall we?
Yeah, go ahead.
Really where people get stuck is, and Patrick hinted at this, is it's the defaults, right? Like people just, they think that, hey, Docker makes everything easy. And that's certainly the marketing, right? Is, you just pull this image. A lot of the marketing, particularly around the stateless, applications have been very much, it allows developers to encapsulate a series of concerns, and then you just hand over the image and then ops will run it, right? Like that was part of the initial messaging around containers and Docker and all that kind of fun stuff. And I think that helped sell it a little bit, but it also did things a little bit of a disservice, to be brutally honest, right? You do need to understand how the network works. You do need to understand how disk impacts performance, right? And so that act of just pulling the Cassandra container will really get people kind of stuck, right? And you look at the way that people have set up things like the default Docker images, the published stuff on the hub, like it's all geared around getting started really quickly. And that's great from like a developer experience, like, hey, I just want to run Cassandra on my machine. But the problem is then people take that into production, right? And that's where they get, kind of burnt because they don't understand what's going on, right? So we spent a lot of time, we made sure that the data volume of our database was on a blind mount to a real file system like, XFS or ext3, right? You've got to look at it, what's going on with the networking, right? You want to have host-based networking, right? You don't want to touch any of kind of the pass-through or the translation stuff that impacts performance. And once you kind of get past those two like major hurdles, it's actually a pretty good experience, right? But I certainly think that the container ecosystem has kind of, with their focus on ease of use and stateless applications, has kind of done a little bit of a disservice in the future, right? And I think that's also true if you look at like the Kubernetes side of the ecosystem as well, right? You look at, it's very much that you're banging on about the mantra of, cattle, not pets, right? And that was kind of very much the idea, right? And to the point that they almost treated, at least in the early days, stateful applications like databases with a certain amount of disdain, right? You even look at the initial name they gave to working with stateful applications, pet sets. It was like, oh, look, you're treating these as these pets, right? And you can get away without needing to do that. Yes, you've got to maintain identity and which disk goes where and all that kind of stuff, right? But I think, certainly the ecosystem around containers has had to do a little bit of growing up when it comes to, the database story and that kind of thing. What's your take on that? I don't know. I'm throwing a little bit of shade on a community, but I think they've matured a lot. I will give them that. They've matured a lot for sure.
It has matured a lot. Well, there's been a lot of confusion in the Docker community already. It's like, wait a minute, Docker's going away. No, it's still here. But I also think, let's not fool ourselves. You're not going to get bare metal performance always. And it's mainly because of the way we deploy containerized databases. It's usually on a single large server or something. So you're going to be sharing CPU, disk, and memory in a lot of cases. So in a lot of cases, that's an all right thing. You're not looking for every absolute millisecond of CPU time out of the particular machine. But I mean, there's going to be a little bit of a performance hit here and there. And I don't know if you agree with that, Ben, but
you can get bare metal. Like, I mean, it is a process running in Linux at the end of the day, right? And it comes down to how do you do it. If you're going to do multi-tenancy, for sure, you're going to have a bit of a hit, right, on performance. But if you run a process, in a container, it's the only thing. You're kind of just, using it, say, as a packaging tool, for example, right? Like, your performance is going to be exactly the same, right? At the end of the day, especially if you've got, nothing else, as you would with a dedicated server running on that. And really, it comes back to the ecosystem, the way they message and, try and, deploy things. And again, there's nothing wrong with that if you're like, hey, I've got a preference of being able to like get more utilization out of my servers, or I want to be, it needs to be easier to manage this, right? They're all good reasons to give up that performance for sure, but you can do it if you need to.
Well, you can. And but I think from my experience of coming from like a long time in ops, we did the same thing with virtual servers, and we packed as many as we possibly could onto a single piece of hardware. And it brings up another problem that I think some folks run into, especially with the distributed database, is that they're using a distributed database for fault tolerance, and they put all of the images on one physical server. And then when that one physical server goes offline, like half their cluster disappears. I think this is also maybe a downside of containers, is it gets you away from understanding exactly what your physical data placement looks like. Because it's like, well, it'll take care of it. Let Kubernetes or something. But you can't trust in that, because what's going to happen is you're going to wake up one morning and find out you have data loss issues.
Reminds me of the SANs of old, right? Like storage area networks, right? You think, oh, it's like, hey, it's just a disk. And then you forget that it's actually like essentially one giant disk sitting in a data center somewhere, right?
Yeah. Well, we used to say this all the time in Cassandra land with SANs. If you don't have a single point of failure, we'll provide one for you.
I want to understand you folks talked about that a bit, but what kind of patterns you have seen where people, because it's just, configuration and settings problem, what kind of pattern you have seen where people make those mistakes? And you did touch upon a lot of those, and how to do it right, how you folks do it right. Let's talk about that.
The first step is for people to understand what they're deploying, right? And that means having a look at, what's the Docker build file, right? What's the Helm chart that they're deploying? What's the Docker swarm file they're looking at, right? They've got to understand everything that's kind of going on under the hood, right? And once you understand that, you can start to make some rational decisions about placement, operations, right? What do you do when a pod goes down? What do you do when you need to rebuild a particular disk? What do you need to do when all those things happen? And does the way you're deploying that support it, right? It's funny, what we do at InstaCluster, we use Docker really in a very basic way, right? Like we don't run it on Kubernetes. We don't multi-tenant. We don't do any of that stuff. What we do is, to be fair, we use it as like a glorified package manager, right? We deploy one Docker image per virtual machine, right? We'll pull that down, run it, gets bind mounted to, the right file system for the data directory, shares host networking, right? So we don't have any overhead around that. And so really we're just using it as a dependency management tool, and to encapsulate all that and to roll that out, which is, one of the great promises around Docker. And that allows us to do that, across virtual machines, bare metal, whatever kind of configuration you want to do. Now, the trade-off is, we don't get all the great density that you'd get if we were to do this, say, on Kubernetes. But I think for particular applications like Cassandra, where people tend to have reached the limit of scaling, say, another database that can be a little bit smaller, is that tenancy tends to be less of a concern, because the size of or the volume of data kind of dictates that, hey, you're going to be on servers anyway, or single servers anyway. So that's how we do it. If we were going to go and rebuild InstaCluster today, would we choose Kubernetes? 100% we probably would. It makes a lot of those choices that we had to make in the early days a lot easier. But, we would spend a lot of time understanding what Kubernetes is doing under the hood and what we're actually genuinely telling Kubernetes to do, right? I really love the concept that, like, computers only do what you tell them, right? It's just figuring out the right way to tell them what to do. And so, you've got to spend a lot of time on that.
Garbage in, garbage out. Yeah. Well, and we do at Datastacks, we do run all our containers using Kubernetes, and it's a challenge. Kubernetes is not quite there for databases, and so we find ourselves having to become subject matter experts at stateful workloads in Kubernetes beyond the state of the art. So pushing the state of the art. And I think that's where most containerized databases are going to be for a while. If you're just running a single container on your laptop, easy. If you're running a few containers in Terraform, not so bad. When you're deploying full data centers of containers, you really need to start thinking about Kubernetes, because that's what it was built for, building virtual data centers of containers. And but at that point, you're now getting into a whole new realm. What I think is really interesting is what a lot of the cloud providers are doing now. And I think it's interesting how they just finally folded and said, fine, Kubernetes is the standard. So now you have an Amazon Kubernetes distribution, and you can deploy Kubernetes applications in any cloud. it's turning a cloud into this kind of like a commodity electricity thing. Here's your plug. Just you can get 120 volts out of it. Great. Or that's probably not everywhere, but in the US. But I mean, when we talk about running containers for databases, much like Ben said, it is kind of an application packaging, but it's also starting to get to the point where we're decomposing parts of a database even more. One of the biggest sins you can commit in trying to put a container together in your Docker build file is trying to lump up multiple processes inside the same container. We've taken an opposite stance where we're just trying to break things out, because Cassandra is very complicated. It can be very complicated to run sometimes, but if you break out the individual pieces, then you're starting to really get into what containers are good for, which is taking individual compute pieces and gluing them together in an orchestrated fashion. And that's why Kubernetes is such a good play here. But I hate to tell people that, okay, you got to upgrade your sophistication level to do this, but that's why we're engineers. We like to build and tinker and make new things. And if it was all boring, then why would we do this, right?
Yeah. I mean, it's funny you touch on the complexity of Kubernetes, and, if you're using it, you're 100% signing up for that. But to be fair, like if I'm going to go run and build, complicated application that's, distributed microservices under the hood, uses a number of different databases as well, right? Like, because let's not be wrong here, we live kind of in a polyglot persistence world, right? If I was to go do that without Kubernetes, but hey, it's going to be on the cloud, like, you've then got to be an expert in whatever cloud provider it is. And, the last time I looked at the Amazon product catalog, like, it's a heck of a lot more confusing than the Kubernetes API documentation, which is, already a beast in itself. Then I've got to be an expert at, whatever config management tool I choose, all that kind of thing. So it's just really about, what do you want to learn? What do you already know? Choosing the right trade-offs. And I think Kubernetes is a great choice because it's that open API to the cloud, right? You just tell Amazon, hey, give me a Kubernetes cluster, and then you may as well be running anywhere, right? At the end of the day, there is some bleed through about understanding how some things work, but it's way less than what you'd need to if you're going to try and say, just, hey, I'm going to build this all on Amazon, just using, Amazon native primitives.
Yeah, well, I hear this a lot, like, oh, cloud is eating open source alive. Well, open source strikes back. I think with Kubernetes and containers, open source gets the last laugh, because cloud's trying to get you locked into their services as a walled garden. But with Kubernetes, you're creating virtual data centers that are totally portable. So when we're asking the question, would you run a database in a container? Well, would you like a nice fixed connection into a walled garden, or would you like something that's somewhat portable? And this opens up so many more possibilities. You can run a standard configuration through your CI/CD pipeline. This whole thing around GitOps, where you say, here's my configuration in a YAML file, my deploy YAML. And now I can deploy it in any cloud or in my own data center or even on my laptop, but that might make my laptop a little hot. But anyway, we could try. But I've tried to deploy a big Cassandra cluster on my laptop, and whoo, there's a lot of machines running. But it's that portability. This is what I love about the open source. It's always disruptive, because it's not just free as in beer, it's free as in freedom. And containerizing a database makes it portable. And, using Kubernetes makes it composable anywhere. And that, as an open source guy, it's exciting for me.
I was curious that how does Edge, 5G is enabling a lot of Edge also, how does that make things, as you're talking about, you can run it anywhere. Yes, Edge use cases are growing. What does that mean for Cassandra? Of course, containers and Kubernetes is what is they're running in Edge. And we're not talking about IoT devices. We are talking about Edge data centers.
Yeah, there's some really interesting versions of Kubernetes out there. I think one of them is K3S or K3D.
Yeah. There are a lot of lightweight, K0 is from Mirantis, K3S is there from Rancher and SUSE. So there are so many. Yeah, so this challenge of because with what is happening is they are not sending everything back to the cloud. They are processing everything locally itself at their edge centers. So which kind of goes back to the point that you're making. You can be running it anywhere you want.
And the state of your data is relevant where you are, but there is a need for replication. And having distributed databases that can replicate without much configuration is really the important thing. And I think in the next 10 years, as you're looking at like the kind of data use cases that we have, the databases are keeping up with that. If you're thinking about a fixed one server database, sure, Edge is a horrible choice. Unless you just need that data for a few minutes. And then if it's ephemeral, you can move on. But rarely is it always ephemeral. So we've already been doing distributed for a long time. And you look at how we analyze data, how we move data around, the Kafkas, the Pulsars, the Sparks, the Flinks. We're good at this. We can manage this. Cassandra with all its data everywhere. Edge is just going to be a smaller and further away use case for that paradigm that we've already created.
Let's switch the topic and quickly talk about the community. You're both, very deeply involved with the Cassandra community. So what's new going on with the community? Do you want to talk about it? I mean, of course, it's open source, so there is no roadmap as such, but just let's talk about the state of community.
Well, I think the big thing on everyone's mind for the Cassandra community is the upcoming 4.0 release. Patrick, please correct me if I'm wrong, but I think, the release candidate is about to get cut or has been cut. I haven't checked the dev mailing list lately, so... But yeah, I'm pretty excited about the 4.0 release. It's been a while in the works, but we're certainly looking forward to, I think, probably the most stable release of Cassandra that we've seen probably ever, to be honest. So pretty pumped about that.
I'm going to take that one step further. I think this will be the most stable database period release ever. It's the amount of testing, the amount of production workloads that have been put against it, the amount of checks for data loss, for data integrity that have been happening over literally years. And the fact that the Cassandra 4 beta is being run in production in a lot of really, really large workloads, and it's working just fine, no issues. And this is an open source database. You're right. You said there's no roadmap. The roadmap is ship it when it's ready, right? It's not. There's no one from marketing going, it's time to ship this thing. We're going to have a party next week. No. It'll be ready when it's ready. But I would encourage everyone who uses Cassandra to give it a try now. Like Ben said, the RC is going to get cut here pretty soon. I saw the traffic, but there are people using beta. We really could use a little more looks just to be sure, but I'm pretty confident this is going to be a really amazing release.
Ben, Patrick, thank you so much for taking time out and talk about not only the work that you folks are doing as the company that you're working with, but also Apache Cassandra, and especially the challenges. And you shared some playbook there, how to do things correctly when you are talking about stateful workloads, databases in containers. So I really appreciate the discussion, and I look forward to talk to you folks again. Thank you.
Thanks, Bob.
Thanks so much.